Perfection has always been the standard. In gemstones, the rule is simple. The fewer the inclusions, the higher the value. Clean, clear, flawless. That's what defines rarity. But that rule doesn't hold everywhere, because in some stones, removing the inclusion doesn't improve the gem. It destroys the only reason it exists. These are not gemstones that survive despite their flaws. They are gemstones defined by them. Internal fibers that create movement, needles that build structure, liquid trapped for millions of years, still shifting inside solid crystal. What looks like imperfection is sometimes the entire mechanism behind what makes the stone valuable. And almost all of these formations come from one place where geological conditions push far beyond stability. Africa. Starting at number 10, with a stone that proves something most people never expect. Sometimes the flaw is not reducing the value, it is the value. Ranked 10th, tiger's eye. Perfection is supposed to define value. In most gemstones, clarity is everything. Fewer inclusions, fewer internal interruptions, a cleaner structure. That's the rule. And for decades, that rule has shaped how stones are graded, traded, and understood. But this is where that rule begins to fail. Because in this stone, what would normally be rejected is the only reason it exists at all. Tiger's eye does not hide its inclusions. It depends on them. Deep inside the stone, countless parallel fibers run in tight formation. Remnants of an earlier mineral structure that has been replaced over time, yet never fully erased. These are not random imperfections. They are aligned, organized, precise. And when light hits the surface, those internal fibers begin to interact with it in a very specific way, creating a moving band of reflected light that seems to glide across the stone. Not fixed, not static, but shifting. This effect is known as chatoyancy, and it only exists because of those internal structures. Remove the inclusions, and the effect disappears completely. What remains is not a better stone, it is an empty one. This is where the idea of flaw starts to break down, because in tiger's eye, clarity does not enhance value. It erases the very mechanism that gives the stone its identity, and that creates a different kind of hierarchy, not based on how clean a gemstone appears, but on how effectively its internal structure interacts with light. Two stones may look similar at a distance, but under movement, under changing angles, one begins to come alive while the other remains still. Collectors don't ignore this difference. They study it. They rotate the stone slowly, watching how the band forms, how sharply it moves, how consistently it holds its line. Because the more defined that internal interaction becomes, the more the inclusion stops being a flaw and starts becoming a feature that cannot be replicated, cannot be corrected, and cannot be replaced. And that's the point where traditional grading systems stop applying, because this is no longer about removing imperfection. It's about understanding which imperfections are essential. And once that shift happens, the question is no longer how clean a gemstone can become, but how much of its internal structure can be preserved without losing what makes it unique. Starting from here, every stone that follows will push that idea further into structures that don't just affect appearance, but redefine what value actually means. Ranked 9th, rutilated quartz. In most gemstones, inclusions are something to search for. Tiny, hidden details only visible under magnification. They are meant to be subtle, easy to overlook, because the closer a stone gets to looking empty, the more valuable it becomes. That's the expectation. But this stone doesn't follow that rule at all. Here the inclusion is not hidden. It's impossible to ignore. Thin strands run through the crystal, sharp, defined, and often crossing from one end to the other. Gold, copper, sometimes deep black. Not scattered randomly, but suspended inside the quartz like a structure that formed before the crystal ever finished growing. This is rutilated quartz, and what appears to be a flaw is actually a second mineral, rutile, crystallizing inside the host as both materials form together. Two structures, two timelines, occupying the same space. Instead of reducing clarity, these internal needles create something else entirely. Depth, because the eye no longer stops at the surface. It moves inward, following each line, tracing each intersection, trying to understand how something so ordered could form without design. And that's where the perception of value begins to shift. A perfectly clear quartz reflects light, but this refracts attention. No two stones are ever the same. Some are sparse, just a few strands suspended in open space. Others are dense, a network of intersecting lines that begin to resemble architecture. And unlike surface features that can be polished away, these structures are locked inside the crystal itself, permanent, unchangeable, which means the inclusion is not a temporary imperfection. It is a fixed condition of the stone's formation. Collectors don't try to avoid this. They evaluate it. They look at orientation, density, color contrast. Because the more defined and intentional the internal structure appears, the more the stone begins to feel less like a crystal and more like something constructed. Not by human hands, but by conditions that cannot be repeated on demand. And that creates a different kind of rarity, not based on how few stones exist, but on how few form with inclusions that look this precise, this visible, this impossible to ignore. At this point, the idea of flawless starts to lose meaning, because removing the inclusions would not improve the stone. It would erase the very reason anyone would choose to look at it twice. And what comes next pushes that idea even further, into patterns so structured they begin to look intentional. Ranked 8th, Trapiche emerald, Africa occurrences. Most inclusions don't organize themselves. They appear as fractures, clouds, irregular interruptions inside the stone. Unpredictable, uncontrolled. That's what makes them flaws. But this doesn't behave like a flaw at all, because instead of randomness, there is structure. At the center of the stone, a core forms. And from that point, dark lines begin to extend outward, dividing the crystal into distinct sections. 6 arms, radiating evenly, almost like a wheel. This is known as a trapiche structure, and it creates something that shouldn't happen in natural formation. Symmetry that looks deliberate, not polished, not cut, but built into the crystal itself. These internal divisions are not surface features. They are zones where different materials, different growth conditions, and different impurities became locked into place as the crystal expanded outward. Which means the inclusion is not interrupting the gemstone. It is organizing it. Each segment grows under slightly different conditions. Each boundary marks a shift, a moment where formation changed direction but never lost balance. And that balance is what makes it so difficult to replicate. Because most crystals don't grow evenly. They shift, they distort, they lose symmetry over time. But here, the pattern holds. Not perfectly, but consistently enough to create a structure that feels intentional. From a distance, it may look unusual, but up close, it becomes something else entirely. A system, a formation that reveals not just what the stone is made of, but how it grew. And that changes how value is perceived. Because clarity no longer defines quality. Uniformity doesn't either. Instead, collectors look for something far more specific. How complete the pattern is. How clearly those radial divisions form. How balanced the structure remains from center to edge. A perfectly clean emerald may reflect light. But this tells a process, a sequence of events locked into geometry. And removing those internal divisions, removing the inclusions, would not improve the stone. It would collapse the pattern entirely. Because without them, there is no structure to observe, no anomaly to question, no reason to look twice. At this point, inclusions are no longer just visible, they are becoming organized. And what comes next breaks the expectation even further. When two completely different materials begin to occupy the same space, in ways that shouldn't be compatible at all. Ranked 7th, Hematite quartz. There is a moment when expectation fails completely, not because something is rare, but because it looks wrong. Transparent crystal is supposed to feel light, open, unobstructed. Metal is the opposite, dense, opaque, grounded. They belong to different systems. They form under different conditions, and they are not expected to exist together in a way that can be clearly seen. But in this stone, They do. Inside the quartz, dark red to metallic black structures begin to appear. Not as stains, not as surface deposits, but embedded within the crystal itself. This is hematite, an iron oxide mineral that formed alongside the quartz and became trapped as the crystal continued to grow. Two materials, one transparent, one opaque, occupying the same internal space without merging into each other. And that separation is what creates the tension, because the eye tries to resolve it, to understand how something solid and reflective can sit suspended inside something that allows light to pass through. But it never fully makes sense. Instead, the contrast becomes the point of focus. Light enters the quartz, then stops, interrupted by metallic structures that do not transmit it, do not diffuse it, but absorb it, reflect it differently, create sharp boundaries where none are expected. This is not subtle. It doesn't require magnification. The inclusion is immediately visible and immediately disruptive, which forces a different kind of evaluation. Because this is no longer about clarity, it's about interaction. How the transparent host and the opaque inclusion coexist without losing their identity. Some specimens show fine dust-like distributions. Others reveal bold internal formations, plates, clouds, or concentrated masses that appear almost suspended in motion. And in each case, the value is not reduced by their presence. It is defined by how clearly that contrast is preserved. Because if the quartz were completely clear, there would be nothing to interrupt the light, nothing to create tension, nothing to question. At this stage, inclusions are no longer just structures or patterns. They are becoming conflicts, interactions between materials that shouldn't share the same space, yet remain locked together in a stable form. And what comes next pushes that idea beyond structure and contrast into something far more difficult to explain, because it doesn't just sit inside the stone, it moves. Ranked sixth, Enhydro quartz. Something inside this crystal refuses to stay still. It doesn't reflect light like a surface. It doesn't scatter like a fracture. It shifts, slowly, almost imperceptibly at first, until the stone is tilted and the movement becomes undeniable. A small pocket sealed within the quartz contains liquid, not residue, not a trace left behind, actual fluid. Water, sometimes mixed with gas, trapped during the crystal's formation and preserved as the structure closed around it. This is Enhydro quartz, and unlike most inclusions which exist as solid interruptions, this one remains active, encapsulated, but not frozen. The liquid moves because it was never meant to be part of the crystal itself. It was captured, locked into place as the quartz grew layer by layer, sealing off a tiny environment from the outside world. And what remains inside that sealed space is not just material, but condition, pressure, composition, a fragment of the environment that existed at the exact moment the crystal formed. Which means this inclusion is not just a feature. It is a preserved state, something that has remained isolated for millions of years, yet still responds to movement today. Tilt the stone, and the liquid slides. Pause, and it settles again. No polishing can remove it. No treatment can recreate it. Because it was never added after formation. It was there from the beginning, and that changes how the stone is understood. A perfectly clear crystal reflects light with nothing to interrupt it. But this interrupts time, because the viewer is no longer looking at a static object. The eye is tracking motion inside something that should be completely solid, and that contradiction is what holds attention. Collectors don't look for clarity here. They look for evidence. How clearly the pocket is defined, how freely the liquid moves, how intact the internal cavity remains. Because the more complete that sealed environment is, the closer the stone comes to preserving a moment that should have disappeared long ago. At this stage, inclusions are no longer just visible and no longer just structural. They are becoming temporal, fragments of formation that continue to exist inside a finished crystal. And what comes next goes even further, into structures so complex, so layered, that clarity itself stops being a useful way to describe them at all. Ranked fifth, included tourmaline. Clarity works only when a gemstone can be reduced to a single condition, clean or included, transparent or interrupted, a simple scale. But that scale begins to collapse when too many variables exist at the same time, because this is not a stone defined by one structure, it's defined by layers of them. Tourmaline does not grow in a uniform way. Its chemistry shifts during formation. Trace elements enter and exit the structure. Temperature changes alter how color develops, and as a result, the crystal records those changes internally. Not as one inclusion, but as multiple systems overlapping within the same space. Zones of color that transition from one tone to another. Needle-like inclusions intersecting those zones. Internal boundaries marking shifts in growth direction, all existing together, all visible at once. What would normally be considered too much becomes a defining feature. Because there is no single point of focus, the eye moves constantly, from one zone to another, from one structure to the next, trying to resolve what it's seeing, but never settling on a single interpretation. And that is where clarity stops functioning as a useful metric. Because removing the inclusions would not simplify the stone. It would erase the very record of how it formed. Each internal change reflects a different stage, a different condition, a different moment in its development, compressed into one continuous crystal. Some specimens show soft transitions, colors blending gradually into each other. Others reveal sharp divisions, distinct layers that feel almost segmented. In both cases, the value is not found in how clean the stone appears, but in how much information it contains, how many changes can be observed, how clearly those transitions are preserved. Because the more complex the internal structure becomes, the less the stone behaves like a single object, and the more it begins to resemble a sequence, not frozen in one state, but carrying multiple stages of its own formation at once. At this level, inclusions are no longer just features, and no longer just interactions. They are becoming records of change, evidence that the crystal did not form under stable conditions, but adapted continuously as its environment shifted around it. And what follows next moves away from complexity into something quieter, but far more immersive, where the inclusion no longer looks like a structure at all, but like an entire landscape contained within the stone. Ranked fourth, quartz with chlorite inclusions. From certain angles, this no longer looks like a gemstone. It looks like terrain. Green formations spread through the crystal, not in straight lines, not in sharp fractures, but in layers, soft, irregular, stacked in ways that resemble depth rather than disruption. This is quartz with chlorite inclusions. And unlike most internal features that interrupt clarity, these formations create something else entirely, a sense of space. Because the eye doesn't stop at the surface. It moves inward, as if the crystal contains more than one plane, more than one level of structure. Chlorite, a group of minerals often rich in iron and magnesium, becomes trapped during different stages of quartz growth. Each layer forms, pauses, and is then sealed beneath the next. Over time, this process builds a sequence, not visible as time, but visible as form. Some stones show faint, moss-like patterns. Others reveal dense internal formations that resemble valleys, ridges, or suspended clouds of green. And the more defined those layers become, the less the stone behaves like a single object. It begins to feel like a contained environment, not something placed inside the crystal, but something that formed alongside it, which is why removing these inclusions would not improve clarity in any meaningful way. It would flatten the entire structure, because without those internal layers, there is no depth to follow, no variation to observe, no sense of progression within the stone. Collectors don't evaluate this based on how clean it is. They look at how complete the internal scene appears, how many layers can be seen, how distinctly those layers separate from one another, how naturally the forms transition across the crystal. Because the value is not in transparency, it's in immersion. The ability of the stone to hold attention by creating the illusion of something larger contained within something small. At this point, inclusions are no longer just marks or structures or even interactions. They are becoming environments, self-contained systems that form gradually and remain preserved inside the crystal. And what comes next pushes the idea even further, into materials that shouldn't remain stable at all, yet somehow do. Ranked third, Chrysocolla chalcedony. Not everything that forms in nature is meant to last. Some materials remain stable for millions of years. Others break down almost as quickly as they appear. Chrysocolla, on its own, belongs to the second group. It is soft, structurally inconsistent, highly sensitive to environmental change. In most conditions, it doesn't survive long enough to be preserved as a gemstone. And yet, in rare cases, it does. When Chrysocolla becomes intertwined with chalcedony, a microcrystalline form of quartz, something unusual happens. The unstable material is no longer exposed. It becomes supported, encapsulated within a more stable structure that forms around it and holds it in place. This is Chrysocolla chalcedony, and what appears inside the stone is not just color, but a record of instability that somehow avoided collapse. Swirls of blue and green move through the crystal, not in clean zones, not in predictable patterns, but in flowing, irregular formations that reflect conditions that were never fully stable to begin with. Unlike inclusions that form through alignment or symmetry, these structures feel unresolved. Edges blur, boundaries shift, colors blend into each other without ever settling into a fixed system. And that's exactly what makes them rare. Because this is not a structure that was designed to hold. It's one that was preserved just long enough to be locked into place. Remove the chalcedony, and the Chrysocolla would not remain intact. It would degrade, fragment, disappear, which means the inclusion is not just part of the gemstone. It is the reason the gemstone exists in this form at all. Collectors don't look for clarity here. They look for balance. How well the unstable material is contained. How evenly the colors distribute without collapsing into disorder. How much of that original, fluid-like structure remains visible without breaking the integrity of the stone. Because too much instability, and the structure fails. Too little, and the defining character disappears. At this level, inclusions are no longer just features to observe. They are conditions that had to be stabilized at exactly the right moment for the stone to survive. A narrow window, where formation, preservation, and structural support align just enough to prevent collapse. And what comes next moves away from instability into something even more difficult to evaluate. Because it doesn't just change how the stone looks, it changes how the stone behaves under light itself. Ranked second, Alexandrite included specimens. Under one light, it appears green. Shift the source, and the same stone turns red. Not gradually, not as a subtle tint, but as a complete transformation. This is Alexandrite, and its defining feature isn't clarity or even rarity in the traditional sense. It's response, a reaction to different wavelengths of light caused by trace amounts of chromium within the crystal structure. But when inclusions are present, that response changes. Because light no longer travels through a uniform medium, it encounters interruptions, microscopic crystals, internal stress lines, tiny structures that alter the path of light as it enters and exits the stone. And instead of weakening the effect, these inclusions can intensify it. Sharper transitions, more dramatic shifts, greater contrast between colors. What appears as a flaw becomes part of the mechanism, because the value here is not defined by how clean the stone looks, but by how distinctly it reacts. A perfectly clear specimen may display color change, but one with the right internal conditions can amplify that change in ways that feel more immediate, more noticeable, more difficult to ignore. Collectors don't evaluate this stone by holding it still. They move it. They change the lighting environment. Observe how quickly the color shifts, how complete the transformation becomes. Because this is not a static gemstone. It behaves differently depending on context, and that behavior is influenced by everything inside it. Remove the inclusions, and the stone may become cleaner, but not necessarily more compelling. Because the interaction between light and structure is what defines its presence. At this level, inclusions are no longer just visible, no longer just structural, and no longer just preserved conditions. They are active participants in how the gemstone is experienced, not altering what the stone is, but altering how it reveals itself. And that creates a final shift in how value is understood, not based on appearance alone, but on performance, on how the stone responds when conditions change. And what comes next moves beyond response entirely into a category where removing the inclusion doesn't just reduce value, it removes the very evidence that the stone should exist at all. In first place, Grandidierite. There are gemstones that tolerate inclusions. There are gemstones that depend on them. And then, there are gemstones where removing them removes the only proof that the stone is what it claims to be. Grandidierite exists in that final category, not because it lacks clarity, but because clarity was never the point. At first glance, the structure doesn't resolve cleanly. Color shifts between blue, green, sometimes carrying a muted, almost uncertain tone that refuses to settle into a single identity. Light enters, but it doesn't pass through evenly. It changes direction, splits, re-emerges differently depending on the angle. This is not a flaw in formation. It is the result of a crystal system that developed under conditions too specific to repeat consistently, where composition, pressure, and temperature align just enough to produce something rare, but not stable in a way that creates uniform perfection. And inside that structure, inclusions are not interruptions, they are confirmations, evidence that the crystal formed through a sequence of conditions that did not remain constant, that something shifted, adjusted, continued, without collapsing entirely. A perfectly clean specimen would raise more questions than answers, because it would lack the internal complexity that proves how the stone came into existence. The boundaries would be too smooth, the structure too consistent, the identity too easy. But Grandidierite is not easy. It is recognized through its irregularity, through the way light behaves unpredictably inside it, through the way its internal features refuse to simplify into a single pattern. And that is where the concept of value reaches its limit, because this is no longer about beauty. It's not about clarity, not about symmetry, not about removing imperfection to reveal something better underneath. There is nothing underneath. What is visible, the shifting color, the internal complexity, the lack of uniform clarity, is the stone. Remove those elements, and what remains is not a higher grade version. It is something else entirely. Something easier to categorize, easier to grade, easier to understand, but no longer the same. At this point, inclusions are no longer features, they are identity. The final boundary between what can be simplified and what can only exist exactly as it formed. And once that boundary is crossed, the idea of perfect no longer applies at all. Perfection looks simple, but these stones prove something else entirely. In some cases, removing the flaw removes the stone itself, because what's inside isn't damage, it's identity, and that changes how value is understood, not by how clean something looks, but by what it contains that cannot be replaced. If this shifted how these stones are seen, the next question is even more extreme. What happens when rarity has nothing to do with structure at all, but with how little of a gemstone exists on Earth? Which would you choose? Perfect, or something with a story inside it?